Hello, sixth grade, and welcome to 4.2. Today we'll be discussing the greatest common factor. And for our objective, it wants us to find the greatest common factor, or commonly referred to as GCF, of a set of numbers. We'll start today by defining the greatest common factor, and that is the largest common factor of two or more numbers. And that's whole numbers. Okay. So in our first example, it says for letter A, find the GCF of each set of numbers. So we're given two numbers, 28 and 42. And in our first method, we're going to use what's called the list method, where we just list out the factors of each number, just like we did in last section. So I'll start with 1 and itself. So 1 times 28, is 28. Next, go to 2. Since it's even, it's divisible by 2. 2 times what number is 28? That'll be 14. 3. Nope, it's not divisible by 3. 4. Yep, 4 times 7. And then we're finished. Okay. Same for the factors of 42. 1 times 42. 2 times 21. 3 times 14. And 6 times 7. And I'm pretty sure I mentioned this in the last video, guys, but for when you're listing your factors, if you need to use a calculator to double check your divisibility rules, go ahead and do that. So if you've tried all sorts of numbers and you're not sure if 3 or 4 is a factor, I'm okay if you do 42 divided by 4 to see if that gives you a whole number. It obviously wouldn't, since 4 isn't a listed factor here. Okay, but feel free to do that. Then you look at your numbers and you see what is the greatest or the largest factor that they have in common. Okay, well, they have 1 in common. They have 2 in common. That's bigger. 3 is not in common. It's just a factor of 42. 4 is not in common. It's just a factor of 28. 7 they have in common. And 14 they have in common. And 21, 28, no, 42, no. It looks like the greatest or the largest number or the largest factor that they have in common is 14. So circle the GCF. I guess I boxed it. And the GCF of 28 and 42 is 14. The greatest common factor of those two numbers is 14. Okay. For letter B, they show you that you can also find the greatest common factor of two numbers by using prime factorization. Okay. Remember with prime factorization that the trick is to use a factor tree. Okay, so if I had 18, I could break it down into 9 times 2, circle my 2 since that's prime, and then break down this composite number into 3 times 3. And when you write out the prime factorization, it would be 2 times 3 times 3, all of my circled numbers multiplied by each other. Okay, so the first step would be to write the prime factorization of each number. All right, for 30, it would be 2 times 3 times 5. And then for 24, it's 2 times 3 times 2 times 2. Okay. Then you need to find the common prime factors. The common prime factors. Okay. So I'm going to box or circle my common ones. So it looks like they all have these 2's in common. And they also have these 3's in common. Okay, so I found the common prime factors. You'll see that there's no more that are common. And then you find the product of the common prime factors. Remember, that means to multiply. So my common prime factors were 2 and 3. So if I multiply those, I would get 6. So the GCF of 18, 30, and 24 is 6. This can sometimes be quicker if you're dealing with more numbers. But you can always do the list method if you prefer that better. So if you wanted to say, well, I'm better at doing the list method 18, 30, and 24, and then list all your factors this way. So 1 and 18, 2 and 9, 3 and 6, so on and so forth, you would come up with the same answer. I'm just showing you this method because sometimes it's helpful to use, and sometimes it can be quicker when you have more numbers. So that's an option for you. Either one here is okay with me. I personally, most of the time, will use the list method. Once in a while, if I've got bigger numbers or a lot of numbers, I'll use prime factorization method. Okay, go ahead and flip to the next side where we've got a little bit more of a word problem. And in this problem, it says Jenna has 16 red flowers and 24 yellow flowers. She wants to make bouquets with the same number of each flower in each bouquet. What's the greatest number of bouquets she can make? Okay, so first step, understanding the problem. The answer will be the greatest number of bouquets 16 red flowers and 24 yellow flowers can form, so that each bouquet has the same number of red and each bouquet has the same number of yellow. We can organize this list in possible bouquets. So you'll see that each one of these bouquets, if we had 16 red and 24 yellow, they filled each bouquet with 3 yellow and 2 red. So that's where you see the 3 yellow, 3 Y's, and 2 R's for the 2 reds. And each one of these, if you counted up your total, it'd be 2, 4, 6, 8, 10, 12, 14, 16 red, and 3, 6, 9, 12, 15, 18, 21, 24 yellow. Exactly what we had here. So the greatest number of bouquets that Jenna can make for this specific problem would be 8. There are 8 bouquets here. 1, 2, 3, 4, 5, 6, 7, 8. So this method of doing it is just a good way to help you visualize it. But realize what the problem is doing here is just finding the greatest common factor of our two numbers of 16 red and 24 yellow. Let's just double check to make sure that's right. Factors of 16, 1 times 16, 2 times 8, and 4 times 4. Notice how they just listed 4 once. Factors of 24, 1 times 24, 2 times 12, 3 times 8, and 6 times 4. So the greatest number that they have in common is 8. Okay? This is just a nice diagram kind of helping you visualize how this problem is set up. Okay? On the check it out section, you'll have to do something like this. Moving on then to the last page, the check it out section. Why don't you go ahead and pause the video now and try 1, 2, 3, and 4 on your own and see what you come up with. Let me know if you have any questions. All right. Number 1, GCF of 40, 16, and 24. So I'm going to do the list method here. Factors of 40, I have 1 times 40. I have 2 times 20. 3, no. 4 times 10. 5 times 8. 6, no. 7, no. So there's all my factors. Quite a few factors of 40. 16, I would have 1 times 16. 2 times 8, and 4 times 4. And lastly, for factors of 24, I know we've done this one a few times. 1 times 24, 2 times 12, 3 times 8, 4 times 6. And now I'm just looking for the greatest of these that they all have in common. So 1, yes. 2, yes. 3, no. 4, yes. I have 4 in common. 5, no. 6, no. 7, no. 8, they have in common. 10, no. 16, no. 12, no. 20, no. Okay, it looks like the greatest of these that they have in common is 8. So the GCF of 40, 16, and 24 is 8. Okay. The second one here is just like that word problem that we finished up just a second ago. And it says Peter has 18 oranges and 27 pears. He wants to make a fruit basket with the same number of each fruit. It's the greatest number of fruit baskets that he can make. Okay, so let's make an organized list again, similar to what they had before. So I'll do my best to make straight lines here. And I've got oranges, and I also have pears. And then I'm trying to figure out how many baskets I can make with all of my fruit. Okay, so again, I have a total of 18 oranges and I have a total of 24 pears. How can I separate these two? Well, let's just try right away making putting 2 oranges in each basket. Again, this is kind of I'm just going to try it out and see. So if I put 2 oranges in each basket, 2, 4, 6, 8, 10, 12, 14, 16. I have to make this a little bit bigger. 18. And that takes care of all my oranges. If I wanted to divide up my pears now and put the same number of pears in each one, how could I go about and do that? Well, I have more pears, so I'm going to maybe put one more in each one to see. Let's try 3 pears in each basket. Okay, so 3 pears. So 3, 6, 9, 12, 15, 18, 21, 24. Perfect. 27. I have 3 pears in each basket, and I have 2 oranges in each basket. How many baskets did I make? 1, 2, 3, 4, 5, 6, 7, 8, 9. I made. Then the greatest number of baskets he can make is 9 baskets. Okay. And again, if I were to look back, essentially all we did is we took the greatest common factor. We found the GCF of 18 and 27. So let's just double check that we did that right. 1 times 18, 2 times 9, 3 times 6 are my factors, the numbers that multiply to get to 18. And 27, I've got 1 times 27 and 3 times 9. That's it. And what's the greatest number that they have in common? Well, that would be 9. Perfect. That's the same thing that we got by diagramming it out. So the GCF of 18 and 27 is 9. All right. That does it for today's lesson on the greatest common factor. get some more practice with this. Let me know if you need help on anything, and I will do my best to do that. Remember to be kind to one another, and I will see you next time.